Hey, welcome back to CodeTav management. Have you ever deployed a Spring Boot application to production, or have you restarted the servers and realized like your entire database are like completely wiped out, or maybe bulk database inserts are running incredibly slow? Okay, so do you know what is the reason behind that? If you know, that is very clear. If you don't know, that masterclass will help you to understand those things better. Okay, so today we are mastering the JPA table mapping and ID generation strategies. Okay, so we are going to look at the dangerous DDL auto property as well, how to properly map the tables and columns, and how to handle the complex composite primary keys. Then most importantly, I can say, like, I am going to show you exactly why using the default identity strategy might be slowing down your enterprise applications, and how to fix it using sequence with allocation sizes. Okay, so let's start with the problem or the danger of the DDL auto. Okay, so before we write any Java code, we have to talk about the spring.jpa.hibernate.ddl-auto. Okay, so this property tells you, like, Hibernate how to handle the DB schema automatically. So it has a few crucial values you need to memorize. So those values are none, update, validate, create drop. Okay, so non-attribute, like non-value, when you will set spring.jpa.hibernate.ddl-auto as none, then what it does? It does nothing. Okay, so that's why this is absolutely best choice for your production. Next is update. So for update, create will be happened, update will be happened, delete will not happen. So updates the schema without deleting your data, which is great for your local dev environment. So written as good for dev. Next is validate. Validate basically only validates the schema and throws the error if there is a mismatch between your Java classes and the SQL tables. And it does nothing like creations, updates, and delete. Only validates the schema. Okay. Next is create. So create will help to create, update, and delete as well. So it drops and recreates the tables on startup, right? Next is create drop. So it also drops the table on shutdown, like, which is the default for H2 or in-memory DB. Okay, so here is your golden rule, like, never use the create or create drop in production. Whenever one server restart, means all your customer data is gone forever. Okay, so create or create drop you need not to use. Whenever you will restart the server, your customer data is gone. Okay, so most of the time we will use the spring.ddl-auto, like spring.jpa.hibernate.ddl-auto as none, right? So our part one done, like the problem of DDL-auto, how to like what values we can pass, what is best for which environment, that we have discussed, right? So next is the next part is at the rate table, at the rate column, and at the rate and indexes. So let's look at the user details entity. So by default, if you don't use the table annotation, Hibernate takes your camel case Java class name and converts it to upper snake case, meaning your you can see that your user details is there, right? This name user underscore details. So if you will have the user detail class, okay, this is your user details class, right? So what it will happen then, by default, it will take these user details, and user details will become like this one. Okay, So if you don't use the table annotation, then Hibernate takes your camel class, Java class name, and converts it to upper snake case, meaning your user details will become user underscore detail. Okay. But what if we want full control? So here you can see we have added one table annotations name, we have kept as user underscore details, schema like it is onboarding, unique constants. Then in unique constants, we have passed the column names phone. So this phone is basically for single column, like, right, you got this for that single column. And when when just a second. Yeah. So when you will give both, like for your composite unique column, then you can set like column names equals to within curly bracket, suppose name, email, both you can set. And indexes also you can use like idx underscore phone column list from your phone column, idx underscore phone. With that, the index will be created. And for multiple, like idx underscore name, email, in that way you also can create. Okay, so what it helps actually, it improves the search performance, but your uh, insertion and deletion, like the modification part, that can be delayed. Okay, so next is here you can see the column at the red column, then name we have passed full name in unique true, nullable false, and length 20. So the optional annotation to like this column you can add as a optional annotation. It's not mandatory, but you can give this to control name, nullability, and length and uniqueness. Okay, so for that you can use. Okay, so now see. So here we don't have the full control, right? So if we will give this name, it will take it and it will convert to the upper snake case. So now we will discuss about the primary keys and the composite keys. So every entity must have a primary key using the at the rate ID annotations, and it must be unique and not null. You have read in database as well, I think. So the primary key should be unique and not null. Okay. So you can only have one ID per entity. So, but what if your primary key requires two columns? Then what you need to do? So for that, like for example, an order ID and a product ID. So we use composite keys. There are two approaches. So one approach is using the ID class, another approach is using embedded ID. So see, like with the ID class, this I have used this class, that user details ck composite key dot class, and passed the entity, and inside this class one at the rate id for your name and another is with address. And here with the entity, here embedded id, see the difference between these two, like this id class, that annotation is in your class level, but your embedded id, that is inside your class. Okay, so that only different. So if you use a composite key class, it must be public, and it should implement the serializable. Okay, so have a nowhere constructor and override the equals and hash code. But why? So that question I will discuss. So if you use the composite key class, it must be public, implement serializable, have a nowhere constructor, and override equals and hash code. But why? So the reason is, like, Hibernate caching uses the hash map internally. Okay. So there is Hibernate caching, and internally it uses the hash map. And without proper keys, the cache completely breaks. So that's why serializable also needed, because these keys may travel across the network in a distributed L2 cache. Okay, so these are the reason. Right now, the part 4, ID generation strategies. So like now for the most important part of this video is like how do we generate these IDs automatically. So you have mainly three options. First one is with the help of identity. So this relies on auto increment by the database. So it's simple, but there is no batch caching. Okay, so which results in high DB calls during bulk inserts. So this is the auto increment by default. Okay, so that's why it is simple. So you can use in that way generated value strategy equals to generation type dot identity. Now second is sequence. That is basically the enterprise standard. So this is the best for enterprise application. So see, we have used the allocation size equals to 5. So this means Hibernate fetches 5 IDs at once from the database and holds them in memory. So that's why it avoids the hitting the DB for every single insert. So this is a massive performance gain for your large applications. Okay, so sequence generator, there we can pass the name, sequence name like user sequence, initial value, and the allocation size. And then in the generated value, we can set the strategy as generation type dot sequence and generator equals to user sequence. Okay, so next is table. So this uses a separate database table to generate the IDs. It avoids the real systems because it is slow and causes locking issues. So table mainly uses a separate database table to generate the IDs. But in real time, don't use this because it is slow and causes locking issues. Now some interview quick Q&A I will discuss. So like the difference between the validate and update. So here we have discussed already. See, like for validate, it does nothing. Like for creation, updation, deletion, nothing is happened. It only validates the schema and if any issue, then it throws the error. But update, what it does, update helps to create or update without delete. So update schema without deleting data. So this is good for dev environment. Okay. So the thing is validate only checks the schema and update actually modifies the schema. Now, can we have multiple ID annotation? No, you must use a composite key class instead. See, here we have this composite for composite keys only. We have the composite class like user detail ck dot class, and then this is the ID class, and then we have passed this multiple ID at the rate ID, right? So when you will use the composite key, then it will be okay. Now, what is the fastest ID strategy? So sequence is the um, uh, fastest ID strategy, and if you will keep the allocation size with greater than 1, that will be best. Okay, so that I have told you as well. Like that's why whatever allocation size you have, suppose 5 it is, so this means Hibernate fetches the 5 IDs once from the database, and it will hold them in the memory. So it avoid the hitting the DB multiple times. Okay, so okay, now our next question is like why avoid the table strategy? So because it uses extra table, and that's why some row level locking can be there and requires multiple DB hits. Okay, next is difference between unique constant and index. So unique basically enforces strict data integrity rule, while index just improves the database read performance, but your insert or update performance will be lower if you will use the index. Okay. So unique mainly enforces the strict data integrity, but index just improves the database read performance. So in your production, one golden rule you need to remember. So we should always use sequence for ID generation and never use create or create drop for schema management, as whenever you will restart your server, it will drop your whole data, whole customer data. Okay, that's the problem. So I think this class helped you. So just hit the like button, subscribe to CodeTav Management, and I will see you in the next one. Okay. So it will motivate me. Thank you, everyone.